Okay, so we know y equals x squared. Which way does y equals x squared open? What's the stretch factor? I'm going to put in a 1. You know, but you could say none. There is no stretch factor. I don't know. I like 1. Is it expanded or compressed? Have we really talked about expansion or compression?
Neither.
Well, in terms of, so based on, actually, let's go to this. And then let's go to this. That's where we're staying in London. Let's go to this. Sorry.
I just realized he was showing
It's frozen. Okay. Y equals x squared. Y equals x squared. What did I mess up? Oh, just talk about slow. Okay, let's move this down because we know that it opens up and blah, 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 right? Okay. If I then enter y equals 2x squared, then we know it's a vertical stretch by a factor of 2. Is it expanded or compressed? Okay, this is the new one. So in a vertical direction, is it being expanded, not horizontally. In a vertical direction, is it being expanded or compressed? Let me do this one. Let's do one more. Y equals 1/2 x squared. Okay, so compared to this, is this expanded or is it compressed? This one. Vertically, we're talking up in an up-down direction.
Neither.
It's vertically no English.
It's vertically expanded, right? And compared, this is 1/2 x squared, it is compressed. Okay? If we're talking horizontally, that's a horizontal compression, right? But we're talking vertically, right? We won't do horizontal until next year. Okay? And then we'll talk about, and the thing with the quadratic is, a stretch can actually be interpreted as either a vertical or a horizontal stretch. That won't be true with anything else, right? It's just quadratics happen to be very nicely symmetrical about this line of symmetry, which runs through the vertex and blah, 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 right? So that's why really we're going to de-emphasize expansion or compression, okay? So if you are going to use those words, you need to use them in conjunction with another description, right? So we would say it's vertically stretched by a factor of 2, which results in a vertical expansion. Okay? We would never just say vertically expanded by itself. Okay? We'll put it together with something else. Okay? So, where are we going? Okay, so is it an expansion or compression? If it's not stretched, then it can't be expanded or compressed. Where is the vertex? How do I write it? Yeah. Okay. It's a point. It has parentheses and it's not a list of numbers, right? It's a point. What's the graph look like? Okay. So just a basic parabola, right? I'm assuming that's what they want. I don't know what else it could be. What's the equation of the axis of symmetry? What's the domain? What's the range? Okay, so I'm just writing sort of not the whole fancy thing, right? Because there's not much room to put the set of all x such that x belongs to the reals. So we can give an abbreviated domain and range, understanding that if we were actually communicating this, do the whole set thing. Maximum or minimum y value and the x value when it occurs. So max or min? Okay, minimum value of? No, minimum value of 0 when x equals? Okay, read the question. X-intercepts, or intercepts.
0.
What, meaning there's none?
Okay, 0, 0.
Okay, intercepts are numbers. They're not points. You could go the point at which the x-intercept occurs and then give it as a value, right? But the intercepts themselves are numbers. The x-intercepts are the values of x where the graph crosses the x-axis, and the y-intercepts the value of y where it crosses y. Will there always, how many x-intercepts could there be? 1, 2, or none. How many y-intercepts are there?
1.
Oh wait, no, it has to have.
So there is how many y-intercepts?
1.
More than that?
No.
Fewer than that?
No.
There is exactly one y-intercept.
0.9.
You will always get a y-intercept. How do you get, given the equation in, well actually, yeah. Yeah, in standard form, given the equation, how do you figure out the y-intercept? You set x equal to 0, right? In general form, you just take the constant term. So general form, really, the only thing useful about general form is finding the y-intercept. X-intercepts and everything else from general forms, no, it's not that easy, right? But from standard form. Okay, so these guys are all what kind of transformation?
Big transformation.
Okay, so these are vertical, right? What's this got going on?
Horizontal
Stretch and then
going down.
and then still
Stretch factor.
In words, what's the first transformation?
The direction
Stretch.
horizontally. Okay, it's reflecting.
In words, what's the first transformation?
Direction of the opening changes.
It is vertically stretched
By a factor.
by a factor of 2
Oh wow.
about the x-axis, resulting in a vertical expansion. That's how we do it in words, right? So it's the full meal deal. It's a vertical stretch. It's not actually asking you this here, right? But I want you to keep this in mind. You are going to describe transformation. You need to do it in words. You need to be able to do it because if you're given a graph and I say, now draw me the transform graph, then you need to say the first thing I do is a vertical stretch by a factor of 2 about the x-axis. You don't need the expansion thing at that point, but you might want to keep that in mind, resulting in a vertical expansion. You will never say it's vertically expanded by a factor of 2. Never, ever. Okay? Never, ever. You will say vertical stretch by a factor of 2 about the x-axis, and then if you want to, then you say which results in a vertical expansion. Okay? Then what's the next transformation? It's a reflection in the x-axis.
Why can't we reflect it first?
Then what's the next transformation?
I don't know. I think negative 34 is the number.
How is that function? It's vertical.
It's a vertical translation, which way? Up, how much? 14. Okay? So if I want to graph that, I can graph that. I just have to start with y equals x squared, take a number of points, start with a point, vertically expand it by a factor of 2, reflect it, vertically expand, never said that. Vertically stretch it by a factor of 2, reflect it down, and then move it up 14 units. Bing, there's my new point. Take another point, vertically stretch it by a factor of 2, reflect it, move it up 14, take another point. You do a few points, you only need about 5 points, right? Good 5 points. The vertex, 2 points on either side, right? Go 2 points to the right, 2 points to the left. You got 5 points, you graph those 5, it's pretty obvious where your new curve is. Yeah.
So the correct way of saying the stretch thing would be vertical stretch about the x-axis by a factor of whatever.
Yeah, or vertical stretch by a factor of whatever about the x-axis. So when we talk about vertical stretches, we should talk about the line upon which we are stretching, because we don't always have to stretch about the axis, right? We could stretch about any line, but every vertical stretch must take place about what kind of line? He says waving his arm side to side to indicate a horizontal line, right?
Horizontal.
Okay, so you cannot stretch vertically about a vertical line, right? It runs up and down. How do you stretch vertically, right?
You make it stretch.
So how do you stretch about a vertical line?
A horizontal.
You stretch horizontally, okay? Which is beyond what we're doing here, right? But it doesn't hurt to know that. Okay, so let's go to the next page. Let's do one of these. So let's pick one. You pick one. Anything on the next page. Pick one. Let me know which one.
The answer on the test.
1, 2, 3.
First one.
This one?
Yeah, 1/2.
Okay. So, direction of opening.
Opens up.
Opens up. Stretch factor. 1/2. Expanded or compressed?
Expanded. Oh.
Compressed. Vertex.
Yes.
-1 + 2.
-1, 2. Graph.
Too lazy to draw it.
All right, so it's a -1, 2, and it opens down, and it's compressed, so it's going to be
It opens up.
opens up.
Really bad every year.
So it's there, and it's wider, Okay. Or it's squashed vertical. It's compressed in a vertical direction. So if you imagine this, right here it is. If I expand, I pull my arms up, then it gets narrower, and if I compress, push down, then it gets. I hate doing it because now I'm describing horizontal more than vertical. So vertically expanded and vertically compressed.
No words about
Axis of symmetry. No. X equals -1. It's an equation. It must be of the form x equals. Domain. Range.
Y is greater or equal to.
Okay. How do you do the range? You take the vertex in the direction of opening, right? Then you put together those two things. Maximum or minimum value? Minimum value of? So minimum y value of 2 when x equals -1. Okay? X-intercepts? None. Opens. See, we don't need to do anything here, right? Because we know what the graph looks like. Some of you would waste a bunch of time, right? Oh, x-intercepts. I'm going to set y to 0, and I'm going to solve this algebraically. Oh, now I got to use the quadratic formula because these numbers probably aren't nice. And some of you who think will say, hey, so if the range is greater or equal to 2, so that means there's no 0 there, so you know what, there are none. That's the difference between people who finish tests on time and have time to do bonus questions and people who don't, right? Because they just wasted 5 minutes running through the quadratic formula, not even recognizing that the discriminant was negative and that there were no real roots, and continuing on to simplify it and all of that, and do it very nicely and neatly and say, look, Mr. Anderson, this is impressive. Not really. What's impressive is knowing that it opens up and it's above the x-axis, so there aren't any. That's much more impressive than, hey, look, I just wasted 5 minutes trying to solve this. Okay. Y-intercept. What is it? So we put a 0 in here. 0 plus 1 is? Squared is? Times a half is? Plus 2 is? 5 halves. I'd take 2.5. Okay. So, is that it? Good enough, right? So do the rest, work together. If you don't, check your answers with not only the person you're working with, but check with other people as well. If you've asked a few people and you can't figure it out, you can call me over to look at it. I'm not putting a key for this up. Life does not come with them. Tests do not come with them. You have the advantage on these in that you can check with other people, right? So I would probably say do the work on your own. Check it with other people. And then the big thing is convince somebody why they're wrong or why you're right. Okay? Just say, no, that goes up. It opens up, right? Why? Well, it's positive. Oh, okay, yeah. I thought it opened down. Or you've drawn the graph like I was sketching the graph wrong. Right? And you guys said, no, it opens up. Oh, right. Okay, never mind. So let me redo this. Okay?